In this presentation, I'm going to talk about Gluon saturation in proton and its contribution to single semi-hard Gluon production in high-energy PA collisions. For single Gluon production amplitude, one can perform perturbative expansion in terms of coupling constant. For saturation correction, we mean here, it only takes into account a subset of diagrams at each fixed order of the coupling constant. For example, at third order of the coupling constant, we only consider diagrams that are enhanced by two color charges. To see this clearly, let's look at the diagrams. At third order coupling constant, we have three Gluon interaction vertices of the projectile, but we need two color charges. We do not take into account diagrams like these. We have three interaction vertices, but there's only one color charge. These diagrams will be sublating when the color charge of the projectile is large. At fifth order coupling constant, we only consider diagrams that involving interaction of three color charges. These diagrams not only take into account initial state interaction of these color charges, they also contains final state interaction of the color charges after they interact with the nucleus. Going back to our formula, when we square the amplitude, we get the first saturation correction here. It contains two different contributions. One is the third order amplitude squared, another is the crossing term between first order and the fifth order amplitude. How do we calculate this Gluon production amplitudes? We work in the color glass condensate framework. We solve the classical Yang-Mills equations of the scattering of the projectile and the target. And then we define the Gluon creation and annihilation operators using the L-state reduction formula through these classical Gluon fields. And then we define the single Gluon production amplitude using these Gluon creation and annihilation operators. For saturation correction, we need third order solutions of the Yang-Mills equations. The solutions are listed here for your reference. Using these solutions, we calculate the first saturation correction. For the third order amplitude squared, it turns out all these diagrams can be grouped into three categories, depending on how many Wilson lines each term has. We have two Wilson lines, three Wilson lines, and four Wilson lines. Of course, each term has four color charge of the projectile. The dependence on the color structure, that's the dependence on rho P and U, can be nicely reflected in these three diagrams. However, the kinematic factor H1, H2, and H3 cannot be reflected in these diagrams. They have to be calculated by summing up all these diagrams. We do a similar analysis for the crossing terms. All these diagrams can be grouped into three categories, and the color structures can be nicely reflected in these three diagrams. Of course, we have to do a full calculation to know F1, F2, and F3. These results are expressed in terms as a function of rho P and the Wilson lines. We have to average over all the color charge configurations to get event average the result.